will start with 24th MCQ. This is MCQ integration dx upon x square plus 2x plus 1. So I will try to find the last term by applying this formula, middle term square upon 4 into first term. So 2x whole square upon 4 into x square. So my last term should be 1. So I will, this is given actually 2. This is not 1, but given 2. So I will split this 2 as 1 plus 1, and I will write this as x plus 1 whole square plus 1 whole square, which is of the form 1 by x square plus a square, whose answer is 1 by a tan inverse x by a plus c. So it is tan inverse x plus 1 plus c. So your option will be B. Let's try to do the 25th MCQ, where we are given integration dx upon square root 9x minus 4x square. So as your first term is negative, I will take minus common outside from first term and middle term. Now I will apply this formula. Last term is equal to middle term square upon 4 into first term minus 9x whole square upon 4 into 4x square. 81 upon 36 x square will get cancelled out. So I will take plus 81 by 36. Actually I am taking minus 81 by 36. So I will balance that by taking plus 81 by 36. So this will be 9 by not this will not be 36. I'm sorry. This will be 4 4s are 16. So here I will take 81 by 16 and will remove 81 by 16. So this will be 9 by 4 whole square minus 2x minus 9 by 4 whole square. So it is of the form 1 upon a square minus x square, whose answer is sine inverse x upon a. But as the coefficient of x is 2, I will divide it by 2. So answer is 1 by 2. So sine inverse 8x minus 9. I am taking LCM, and that will get removed, or it will get cancelled with denominator of 9 by 2. So your final answer is 1 by 2 sine inverse 8x minus 9 by 9 plus c, which is your B option. Now see, we will try to understand integration by partial fraction. First of all, I will explain you what is the partial fraction. See, here we will convert 1 upon x minus a x minus b as a upon x minus a plus b upon x minus b. This is of the form type 1, where your denominators factors are not repeating and they are in the simple form x minus a and x minus, that is in linear form. So if your denominators are in linear form and the factors are not repeating, that it will go in type 1. So we will write that fraction as a upon the one denominator plus b upon another. If you have one more factor in denominator, then you will take c upon x minus c, and it goes on, right? Then we will discuss type 2, where the factors are still in linear form only, but they are in the repeating form. You can see that here x minus a is getting repeated thrice. So here we'll apply this logic: a upon x minus a plus b upon x minus a whole square plus c upon x minus a whole cube and d upon x minus b. This is your type 2. You can easily understand that here your denominator are still in linear form only, but the factors are repeating. So we'll take them successively. If you have 4, then we'll take the power 1, then 2, then 3, and then 4. Likewise, we will take that. And the third type is you have your denominator as a combination of linear and a quadratic terms. Then we will write a upon x minus a plus bx plus c upon x square minus b. So numerator of the term having quadratic equation, you will take one x and then constant. This is of your type 3. So you will get 3 types of integration in this partial fraction. In type 1, you will have simple linear denominators with no repeating factors. In type 2, you will have uh, linear terms, but the factor will be repeating. And in the type 3, you will have quadratic terms, and I have shown you the assumption for each type, right? So we will proceed with the sum to get this concept rigid, right? So let's try to do the very first sum of your exercise 7.5 to get this more clearly. Here it is given x dx upon x plus 1, x plus 2. As you can see that this expression will fit in type 1, as your denominators are linear. Both of these terms are linear, and it is also not repeating. So I want to write this as a upon x plus 1 plus b upon x plus 2. Give this equation as 1. We will use this afterwards. Now here I am interested in finding the value of a and b. So what I will do is I will cross multiply this x plus 1 and x plus 2 over here. So a into x plus 1, x plus 2 upon x plus 1 plus b into x plus 1, x plus 2 upon x plus 2. You can see that x plus 2, x plus 2, and here x plus 1, x plus 1 will get cancelled out. So I'm left with this equation. Here you can see that critical points how x is equal to minus 1 and x is equal to minus 2. If I will take x is equal to minus 1, then this term will get 0. And if I take x is equal to minus 2, then this term will get 0. So we'll assume the two values of x. First I will assume x is equal to minus 1. So I will replace the value of x as minus 1 You can understand this will get 0. So I got a value of a as 1. Now I will assume x as minus 2. So you can see that the value of b is 2. Keeping these values in this equation, I can write x upon x plus 1 x plus 2 as minus 1 upon x plus 1 plus 2 upon x plus 2. Right. So if I want to take integration x dx upon x plus 1 x plus 2, then I will take integration of right hand side. Here constants will come out of integration. So minus 1 into log mod x plus 1 plus 2 log mod x plus 2 plus 6. So I can simplify this as minus log x plus 1 plus log x plus 2 whole square, and you can see that these two log are in subtraction, so I can write this as x plus 2 whole square upon x plus 1 plus. So this is your final answer. Let's try to do the second sum. Here integration dx upon x square minus 9. See, here you can apply that formula 1 upon x square minus a square. But as this question is given in partial fraction section, we will try to solve this sum using partial fraction. So dx upon x minus 3 x plus. I will factorize this as x minus 3 x plus 2. Again this will get fit into type 1, so I will write this as a upon x plus 3 plus b upon x minus 3. So if I cross multiply this, then x plus 3 x plus 3 will get cancelled, and here x minus 3 x minus 3 will get cancelled. So I will first of all assume x as 3. So 1 into 1 is equal to a into 0 plus b into 6. So the value of b is 1 by 6. If I assume x as minus 3, then I will get a into minus 6 plus b into 0. So I will get a as minus 1 by 6. So if I replace that value, so I can write 1 upon x plus 3 x minus 3 as minus 1 upon 6 x plus 3 plus 1 by 6 1 by 6 upon x. So if I take integration on both the side, minus 1 by 6 will come out of integration, and here 1 by 6 will come out of integration. I will get log mod if I take 1 by 6 common outside, then I will get log mod x minus 3 minus log mod x plus 3. You know that if log is in subtraction, then I can write it in this form plus c. Now if you will compare your answer with that formula, then you will get the same answer. So whichever way you try, the answer will not get changed, right? You will get the same answer. We'll start with the third sum, where it is given mm, x 3x minus 1 dx upon x minus 1 x minus 2 x minus 3. Here you can see that three terms are given in denominator, so I want to write this 3x minus 1 upon x minus 1 x minus 2 x minus 3 as this will get fit in type 1. So a upon x minus 1 plus b upon x minus 2 plus c upon x minus 3. So if I cross multiply this, then I will get this x minus 1 and x minus 1 will get cancelled. So x minus 2, x minus 3 plus b into x minus 1, x minus 3, whereas here it will be x minus 1, x minus 2. So I will take three values. First, I will take x is equal to 1. So 2 is equal to this two terms will get 0. So a into minus 1 minus 2. So I will get a is equal to 1. If I take x is equal to 2, then 3 2s are 6 minus 1, 5. Here this a and c term will get cancelled. So I will have b 2 minus 1 1. This will be minus 2. So value of b will be minus 5. If I take x as 3, then 3 3s are 9 minus 1 8. Here A and B will get 0. I will get the value of C as B minus 1 and B minus 2. So C is 4. So I can write 3x minus 1 upon x minus 1, x minus 2, x minus 3 as 1 upon x minus 1 minus 5 upon x minus 2 plus 4 upon x minus 3. So if I take integration on both the sides, integration 3x minus 1 dx upon x minus 1, x minus 2, x minus 3, then this will be integration 1 upon x minus 1 minus 5 integration dx upon x minus 2 plus 4 integration dx upon x minus 3. So the answer will be log x minus 1 minus 5 log mod x minus 2 plus 4 log mod x minus 3 plus c. So this is your answer.